Quite a number of you will be familiar with something written. What should we go? Let's go for 4 squared. Now we understand those shapes to mean that value there is multiplied by itself, so we end up with 4 multiplied by 4, and that 4 cubed is 4 multiplied by 4 multiplied by 4. Okay, so that's fairly straightforward enough. Let's take this a little bit further. Picking on the value of 3. Now if I got 3 times 3, we know that that is 3 squared. It's just a way of writing it. We know that that represents this. If we have 3 times 3 times 3, because these are multiply, we have 3 cubed, because there's 1, 2, 3. It's multiplied by itself 3 times. Notice that is 2, that is 3. Can we go back the other way? What's the next one down from 2? What does that mean? Let's have a look here, look. 3 raised to the power of 1 come out of equals 3. So that is just 3. There is one more. I will come to that later. 3 raised to the power of 0. Don't worry about that at the moment. So that is just 1 3 there. Okay, so that is a way of writing things. What about if we have, where should we go? 3 squared times 3 raised to the power of 4. Think about them one at a time. That one and that one with a multiply between. Let's do this one first. 3 times 3. We now have that multiply. Now we do this one. 1, 2, 3, 4 with multiply between. Now we got 1, 2, 3, 4, 5, 6. 3 to the 6. Notice that if I add those two together, I get 3 to the 6. And this is true in all cases where there's a multiply. You add those together. Not quite all cases, so let's hold that in reserve. When it's multiply, add those two together here and you get the answer there. That is a nice easy way rather than calculating all that lot out. Right, so multiply, you add. What about if we do divide? What about if we do divide? Suppose we have, I'm going to group it, alright, 3 times 3 times 3. Yeah, we know that that is 3 cubed, right? But it's 3 times that. And I want to divide that by 3 times 3, which in fact we know is 3 squared. But there's a divide. So what we have in fact here, like in 4 divided by 2, we can write that as 4 over 2, which we can simplify and get to. But the point is, you can convert that format into this format, and we totally understand that they're both the same thing. That's with a divide. We've got a divide. So let's write these in that format. We have 3 cubed over 3 squared. Okay, let's write that out. We've got 1, 2, 3 of them. That's the top part. 3 times 3. That's the bottom part. Now if we cancel out, we end up with just 1 3, which, if you really want to be fussy about it, raised to the power 1. Do you remember raised to the power 1? 3 raised to the power 1 is 3. Right? But we don't bother to write it, so we have 3. 3 to the power of 1. Look at these numbers here. 3 cubed. If I subtract that, I end up with 3 to the power of 1. So when you're dividing, you subtract. When you're multiplying, you add. Providing these, what raised to the power, are the same, 3 and 3. You can't have, well, you'd have to fiddle it. There is a way of fiddling it. 3 and 6. No, we won't go there. No. Okay, so the general rule is, for divide, you subtract. For multiply, you add. I mentioned earlier about 3 raised to the power of 0. Now do you remember, for divide, you subtract. Okay, look. 2 raised to the power of 4 over 2 raised to the power of 4. The value here is exactly the same as the value there. So we know that in fact that is 1. But we said if you divide, you subtract. So we have 2 raised to the power of 4, which is the top one. Then we subtract the bottom power, and that would give me 2 to the power of 0. So 2 to the power of 0 is 1. 3 to the power of 0 is 1. As an example, 65 to the power of 0 is 1. I won't say whatever the number is raised to the power of 0. That's not quite true. I have a number there, raised to the power of 0. The bulk of the time it's 1. What about when that is not true? It does not equal 1. It is undefined. The system to get 0 will subtract the bottom from the top. To get this, we'd have to have, and I'm going to say square it. Which equals 0 to the 2 minus 2, which equals 0 to the 0. But you may not have 0 as a denominator. It is undefined. To use a basic word, it's not allowed. It doesn't work. This is a fail for the idea of subtracting the bottom from the top. It does not work. We now need to take this a step further. That little baby confuses a great many people. It really does. You have a decimal point. You have a single digit here. It could be anything between 1 and 9 and including them. So I'm going to pick, say, 5. Right? It could be anything between and including. If that is, say, x, all right, we have x greater than or equal to 1, less than or equal to 9. That means it includes the number less than or equal to, so it includes the 1. No, wait a minute, let's get this right. X is greater than or equal to 1, but x is less than or equal to 9. Think of the size of the gap. This is bigger. Well, there is no gap there. So this side here, whatever's on this side, is the greater value. Whatever is on this side is the lesser value. You get that in something called inequalities, but that's what it means. Now I've decided that I'm going to use 5. And suppose I have 5.269. That is in scientific notation. But suppose I were to say just times 10. 10 is the important value. Okay? 10 is the important value. By what we learnt a few moments ago, if that's 10 to the power of 0, which becomes 1, the actual value is 5.269. Remember, that is 1. But suppose we have 5.269 to the 10. If you like, you can put a 1 there. People don't bother. Its true value, this is called scientific notation, the true value is 52.69. Suppose we had 5.269 times 10 squared. Now, what happens is the decimal point stays put. The numbers shunt that way. And I shunt that way twice. See, that becomes units, it then becomes tens. So this moves to there, then to there, and the 5 moves along with it. All the digits here all move 1, 2 places that way. So we end up, I know people say, oh, move the decimal point. That's not really what's happening. It says you're counting in hundreds. You've got 5 lots of 100. That's the clincher. That's what it's actually doing. So you've got 5 lots of 100 plus a bit of 100. So this becomes 526.9. See, you'd expect the numbers to be hundreds. It is. Look, there's 526. 10 squared is in 100. Whoops. And you got hundreds there. Let's get rid of that. Remember, it's not the decimal point that moves. You're making the values jump to the next, if you like, grade of value up. 10 cubed times 5.269. It's still scientific notation. So now we're counting in thousands. So that is the 1,000. So it moves tens, hundreds, thousands. So we got 5, 2, 5.269, and because we're doing that, we put 0.0. 3 is thousands, 5,000. There's your clue. 2, right, that's hundreds. There's 2 zeros. See, 1,000, 1, 2, 3, it's got 3 zeros. 100, it's got 2 zeros. It can go the other way. Instead of making the number here that they write in scientific notation greater, this is greater, it can make it lesser. We talked earlier about, should I move that across? Have I got space? Let's put a line down here, shall we, when it works. We were talking about 3's and we ended up with, say, 3 to minus 2, which is another way of writing 1 over 3 squared. Oh, by the way, 1 over 3 to minus 2 makes it go the other side. So you end up with 3 squared. If you got 3 to minus 2, I'll put the 1 there, it goes the other side. So we end up with 1 over 3 squared. This tells you to change it either below the line or above the line, depending upon where it is. It says change the position. Okay, now we will be using that idea. Instead of 10 raised to a whole number like that, that is positive, we would have raised to a number that is negative. So if we have here 5.269 times 10 to the minus 1 is still scientific notation. That means the decimal point stays still and all these digits shift that way, one place. Got 1 0, 1 0. Right, so in fact we've got to show the value as a value there, so we put 0 where that is, then we get 5.269. Right, actually I should write that there, shouldn't I? 0.5269. Okay, move it across a bit. 5.269 times 10 to negative 2. Decimal point stays still. The numbers move that way 2 places. So that equals 0.1 place, 2 places, 5.269. It's moved 1 place that way. It's moved 2 places that way. So there's 2 noughts. There's 1 nought. 5.269 times 10 to minus 3 is equal to 0.00, 3 zeros, 5.269. See the way that works. 5.269 times 10 raised to the power negative 4 equals 1, 2, 3, 4, 5.269. Has it moved 4 places? 1, 2, 3, 4. I moved the decimal point then as a check, but what's really happening is the numbers, the digits move that way. The decimal point stays still. Let's look at an example. Question that someone posted on the net. Write the following numbers in scientific notation, and that's the one they got confused about. So we're going to be taking a look at that. scientific notation. If we have, doesn't matter what it is, I'm going to pick on the number 5.0, and I multiply that by 10 squared. That is really 5 times 100.0. That there tells you how many zeros are between the digit and the decimal point. So what about if we have 5.0 times 10 negative 2? What this one has done is moved that 1, 2 places. What this one does, so the numbers actually move in that point. The decimal point stays still. That's hundreds. We've got 5 lots of 100. So in this one, when it's negative, the number moves that way. Here, the number moved 1, 2 places. Here, the number must also move 2 places, but in that direction. So if we have 5.0, it moves 2 places, 1, 2. So it goes there. So we have 0.05. That is hundredths, 1 over 100. 5 lots of 1 over 100. 1 over tens, 1 over hundreds. Right? It takes quite a bit of thinking about. So we have got as a starting point 0.1, 2, 3 times 10 negative 3. So the number, to get as it really is without any of the tens, moves that direction. The decimal point stays still. It moves 3 times. So there's the 1, there's the 2, there's the 3 zeros. It was there. Moves 3 times. 1, 2, 3. 0, 0, 0, 3. It's moved 3 times. 1, 2, 3. Okay, there's the decimal point. That's the decimal point there. So what we have in fact here, we want that to move such that it's where that 0 is. And it has to move 1, 2, 3, 4, 5, 6, 7 places. So we have 3.0 moves 1, 2, 3, 4, 5, 6, 7 times 10 negative 7. Negative makes the digits move that way. Watch it a number of times. Watch it a number of times.